Good morning, class. Today we are doing geometric sequences, day 2, which we are just talking about infinite sums. Geometric sequences will converge. And by the way, converge means it'll approach and get to a sum if the absolute value of the common ratio is less than 1. And that should make sense because if I'm multiplying by 1/2, the number is going to keep getting smaller, smaller, smaller until eventually we're almost like we're at 0. And because of that, that turns our old formula into a new formula. Oh, don't write that. We have an infinite sum formula that just turns into, it's the first term divided by 1 minus the ratio. So when we want to know what the sum of an infinite geometric series is that converges to a value, then you can use that formula. If it's not geometric, you can't use it. If it does not converge, you cannot use it. So otherwise we will say the sequence diverges and we say there's no infinite sum. So let's take a look at this. Number 1, 4, 2, 1, 1/2. Hopefully you guys realize that the common ratio here is 2 divided by 4, 1 divided by 2. No matter what it is, it's 1/2. The absolute value of 1/2 in this case is less than 1, so this series converges. So now I can find the sum. The sum, or the infinite sum, is the first term divided by 1 minus the common ratio. So it's 4 over 1 minus 1/2 is 1/2, which is equal to 8. So what that's saying is if you keep adding fractions up, 1/8, or sorry, 1/2, 1/4, 1/8, 1/16, 1/32, 1/64, and so on and so forth, starting at 4, you will get closer and closer and closer and closer until you're eventually at 8. Okay, if you look at number 2, it goes 8, 6, 4, 2. There's a problem here, and that problem is it doesn't have a common ratio. 6 divided by 8 is not 4 divided by 6, which is not 2 divided by 4. This is actually arithmetic. So it's divergent. Or it diverges, if you want to say that. Alright, so this one down here is geometric, but it's written in the summation form. So the first thing you have to identify is what your R value is. Really easy. The R value is the thing that is being raised to a power. So in this case, our R value is equal to 1/3. Again, the absolute value of 1/3, which is 1/3, is less than 1, so it converges. We also need to know the first term. The first term is when you put, in this case, a 1 in for k. So it's 2 times 1/3 to the first power, which is 2/3. Now we can write our formula, 2/3 over 1 minus 1/3. You end up with 2/3 divided by 2/3, which everyone should know is 1. So again, if you did this summation, wrote out all the fractions, they would add up to 1 if you went off to infinity. Alright, so that's infinite sums. Again, very easy formula. However, you just have to identify what is R. Is it geometric, first of all? And then if so, what is R? If absolute value of R is less than 1, or if the values are getting smaller, the series converges. Alright, talk to you later.